And we should be live. Welcome everybody to another live stream repair. Let's get our text status updated here real quick. So we've got two HomePods in for repair today. First up is actually not going to be Adam, but Jeff's HomePod with death farts. And then we'll move on to Ben's HomePod with no power. There we go. Alright, so here we've got our pod covered up in a nice looking case here. Let's go ahead and get that off. It's been a busy day. I've just got back and getting set up for the stream here, and I haven't had a chance to get quite ready yet, but here we go. We'll be sure to put that back on before we send it back to them, of course. Anyways, here's their HomePod, and they're saying it's got death farts. So what I'm guessing, like many others with death fart symptoms, is going on is most likely too much DC voltage as a result of these filtering capacitors on the back of the amplifier starting to go bad. So once the amplifier detects around 2 to 3 volts of DC offset, I believe it is, it'll produce these death fart sounds and force an unexpected restart. One thing that we can check for, just to confirm that that's what's going on here, without even opening it up, is plugging it into power, waiting for it to boot up, and then waking up Siri on here just to see and listen for how loud of a pop sound we get. The louder the pop, the more DC voltage the amplifier's putting out. It's kind of like putting a 9-volt DC battery up onto your speaker wires here. So the louder that pop will be, the louder we can guess how much DC offset this thing has, and we'll be pretty sure that that's what's going on here with those filtering capacitors giving up. Ooh. So listen carefully for a popping sound when I wake this up. Oh yeah, that's a fair little pop there. Sounds like about 400 to 500 millivolts right now, and if we sit around for a few minutes here, like what Jeff was saying in their emails to us, if we wait around long enough, I'm sure this will start doing the death farts and restarting on us. But we're not going to sit around and let it cook the woofer. We're going to go ahead and tear this apart and see what's going on from the inside. We'll start with our pry tool. Like I always say, we're not using this to actually pry it up. We're just using it to cut through this adhesive. And when you go around enough times, it should basically pop right off for you. That way you avoid scratching or cracking this thing up. Give it up, give it up. There we go. Let's get the display out with these T6 screws now. came up real easy. Oh. Bit of an indent on the bottom of the mesh there. Not sure where that would have come from. They had it packed pretty well. That's okay. It's on the bottom. I'm sure they never noticed it. Because it was packed pretty well. I don't know if that was from it being shipped over here or not. See if we can work some of that mesh back into its original shape when we're all done here. Here we go. Time for the pry. Voice coil looks good, feels good, smells good. Very good. power supply out of there. And the amplifier. Here we go. So, before we do any repairs on this, first thing we always like to do is power it up and hook it up to our test woofer here, which has a connection to our multimeter, so we can get an idea, if our guess is right, how much DC offset we've got going on here. And then we'll replace our filtering capacitors. You know, the usual. Replace that power diode as well for good measure. And then we will give it another test and see if that gets rid of that DC voltage, which causes those death farts. Alright, so logic board, subwoofer, power connector. Let's connect our multimeter to that subwoofer here. And power this up. Keep an eye on the woofer here after this finishes booting and we wake it up. I'm sure it's gonna give us quite a healthy pop and a bit of movement there. Okay. Oh boy. So well past 200 millivolts. Let's jump up to the 2 volt DC scale there. Yep, we've got about 500 millivolts of DC offset coming from this amplifier here. A question I get a lot is actually, what is DC offset? And there's a pretty simple answer for that. At least when we're talking about audio amplifiers here, DC offset is simply just how far away from 0 volts DC you are. You ideally don't want any DC voltage being generated by your amplifier and sent to your speakers, because DC voltage is not what audio is. To be honest with you guys, before I got into these repairs, I always thought that audio was an AC or a DC signal. You know, you look at the back of your speakers, you got a positive, you got a negative. Intuitively, at first, you'd think that's a DC signal. Well, no. Audio is actually an AC signal, or an alternating current. So what happens when you pump in DC voltage to a speaker is, instead of the speaker moving forwards and backwards the same amount because of the alternating current it normally gets, you're giving it DC voltage, so it's going to move the speaker one way or the other and basically keep it there. and that's going to put additional load on your subwoofer speaker. That's going to put additional load on the amplifier, because all the amplifier's job is just simply to amplify whatever it's given. It's not going to filter DC out of the AC audio signal that you feed it. It's just going to amplify whatever it's given. That is an op-amp's job. So there are a few filtering capacitors in line this audio circuit, or in this amplifier here, that are supposed to filter this DC voltage before it gets amplified and sent to your speaker. Just in a talking here for a minute, we can see our DC offset's already grown to around 1.06 volts. If we hang out for just another minute or so, we can probably watch this fart for us live. But we're not going to do that, because I don't like torturing other people's parts here. So, watch this. When we unplug it from power, we're going to listen to the subwoofer speaker here, and it should move quite a bit given how much DC voltage we've got here. Yeah. So that's bad. That's what kills your subwoofer. The amplifier surprisingly has a bit of protection built into this. So if it sees more than 2 to 3 volts of DC offset being produced, it's going to force a restart and play that death fart tone that everybody always calls it. So we're going to take these test parts off, and then we're going to flip this board around on the bench here, take a closer look at what we suspect to be allowing that DC voltage through our amplifier and into our subwoofer. Let's get you guys up close. There we go. So here is our area here on the amplifier board where the audio signal for the subwoofer is taken care of. So here's your DAC. This is the digital to audio converter right here, this specific chip. What this does is this takes the digital audio signal from your logic board over here and converts that to an audio or an analog audio signal. But that audio signal, that analog signal that it generates, is a little too weak to pump into this big speaker here. So what it does is it goes through a few components here before it makes its way to the main amplifier IC. And what this does is, this is what other people call an op-amp. And like I said earlier, all it's supposed to do and all it's designed to do is amplify whatever it's given. So it's expecting to get that AC analog audio signal from back here, and then amplify that, and then send it to your subwoofer. What happens, and this is sort of an inherent thing with most audio amplifiers, is when you convert that audio signal to analog, you're going to inherently introduce a bit of DC voltage in that analog audio signal. So there's a few filtering capacitors right here, these 4 big ones, that are supposed to filter that unwanted DC voltage from your weak analog audio signal before that signal is sent to the main amp to be amplified and sent to your subwoofer speaker. That's typically why, if this is ignored, you could end up blowing out your main amp chip here. You could end up blowing out a few other components on the other side of the board further down the line because, well, it's amplifying a DC voltage. So all sorts of funny stuff can happen to that when these components aren't expecting it. Like I said earlier, there is something on here that is able to detect when there is too much of that DC offset, and it forces that restart and produces that that classic death fart that everybody likes to hear. Xander says, "Let it fart." I can't do that to him. Or should we? Anybody else think we should make it fart first before we fix it, or do we just want to jump into the fix? I'll let you guys decide. let it fart, or fix it first. All right, fair enough. Well, no one's saying anything yet. We're gonna go ahead and fix the poor thing. We're not gonna torture this poor soul. I'll go ahead and dig up, let it fart. If that's mine, you can make it fart. All right, well, we've got blessings from Jeff to make it fart, so let's do that real quick. We're gonna put our power supply back on there real fast. Everyone says fart it, fart it. Alright, we're gonna make it fart. And I'll show you guys how to make it fart a little sooner than waiting around. And this is actually how I figured out the cause of death farts and how to repair it. So what we're gonna do is bring in our hot air gun, and we're gonna heat those capacitors up. And what that does, this is just an inherent design property of these specific types of ceramic capacitors. The hotter they get, the less DC voltage they're able to filter. So once we heat those up, we'll see our DC offset start to spike, and it'll more likely than not fart within a few seconds on us. And every single time it gets me, makes me jump a little bit. I can always expect it, but I just always gets me. Alright, so we're letting it boot up. You guys are crazy, but we'll do it. So we're going to flip this around. I probably should have done that before I plugged it in, but that's okay. We've got our heat here. We're going to wake this up. Get that amplifier out of standby mode. We can see we've got off a cold boot about 600 millivolts, and it's already climbing. Watch this. As I heat up the rest of the board, it's still growing at its normal rate, but as soon as we get to those caps, look at that subwoofer speaker. Look at how much it moves. That's insane. Ah, there you go. Still spooked me. And there it's restarting. So there's your live death fart demonstration for you folks. A few farts won't do much harm, but don't let it continue farting if you start having the problem. Definitely unplug it from power, get it apart, and get those filtering capacitors replaced. So that's what we're going to do here right now. Yeah, I got you guys, didn't it? Alright. Now, just so you know, if you were to go and do that to a HomePod that doesn't have this problem, it's probably still going to fart on you. Reason being, like I said, it's an inherent design property with these types of capacitors. The hotter they get, the less DC they're going to be able to remove. So, different caps have different temperature ratings. These ones are rated X7R, and that's going to be what we're going to replace them with here. We've got ourselves some size 1206, 16 volt, 10 microfarad, 10% ceramic capacitors. If you're curious the exact part number that I used to replace these, or what I used to replace these with, there's your part number. But I've also got all of this information up on my website at the bottom right of the video there, nixfix.com. Just head over to the common issues section, find your issue, and there you'll find the steps that we take here on the channel to diagnose and repair those issues, along with any parts and or specs of those parts that you may need to do it. Okay, so we're gonna get our hot air here, and we're just gonna go to town. There we go. Old caps are off. We are going to put some fresh solder on those pads there. A little bit of flux. Let's get our fumigator on there. Fume extractor, not a fumigator. Lord help us. There we go. Sufficient solder has been applied. Just a little more flux. Look at those just float into place. They do all the hard work for us. Man, the magic of a good flux and solder. How's that look up close here? Oh yeah. I like that. Alright, before we fix this up, we are going to, before we test this, we are going to replace this Schottky barrier diode over here, right there. It has nothing to do with our issue here with death farts or DC offset, but that specific diode there does love to short out and cause the most common problem with HomePods being no power. So while we've got it apart, while we've got it here, we like to always replace this diode regardless of what it looks like, what date code it's got, what the HomePod came in for. We just like to nip that problem in the bud. Come on. There we go. Old diode be gone. Let's prep this new diode. A little bit of flux. Try hearing that while watching a movie with your kids. Yeah, no kidding. Or like in the middle of the night, everyone's sleeping and suddenly you just hear this loud that. You just hear that. And yeah, it's pretty startling to say the least. You think they'd pick something better than just absolutely maxing out the speaker for like an unexpected restart tone there. All right. New filtering caps. New diode. Let's give this just a few seconds in front of the fan here to cool it off before we do our testing. As I said, heat will make those filtering capacitors less effective, so we want to make sure that this is relatively cooled off here before we jump right into our testing. This is Nick. Oh. Oh yes, of course. Yeah, I'm actually streaming right this moment. I don't have you on speaker, so you don't have to worry about that, but oh, is it asking you to like add me as a contact? Are you like trying to do like a bank transfer? Through Zelle. Okay. So for my last name, you can put my my last name, the same one as my shipping address. Just SPLATTS. SP Splats. So S is in Sam, P is in Paul. Yeah. I think the only thing that really matters is the phone number. So as long as you put the right phone number in. Yeah. They don't care what name you put in there. Sometimes it takes up to an hour, so probably by the time I'm done with my stream here, I can check and see if it went through, and I'll let you know. Okay, you got it. Alright, sounds good. Thank you. Oh, of course, this is, I love doing this. Like, bringing this stuff back to life, saving them from the dump. Yeah, you got it. Yeah, no, I'm looking forward to setting up an actual another stream for that one specifically, so we can take a look at it with everyone for the first time. Because I've never actually cracked open an iPad Pro before. So you'll get to watch too, and we'll find out together what's hopefully what's going on. Of course, you got it. Yeah, well, I've got it now. Okay. Of course, you take care. Bye. Alright, sorry about that, folks. That was a previous HomePod repair. I think we did theirs yesterday, and they were just calling to make sure they were sending the payment for their repairs and return shipping to the right person there. So we got them taken care of. They're also going to be sending in an iPad Pro that is having issues that they'd like us to take a look at. Fingers crossed we're going to be able to figure out what's going on with that. Never taken on an iPad Pro repair before, but I'm always down for a new challenge. And I'm sure you guys would like to see it too. So, we've got our HomePod here. It's powered on, but it's not yet out of its default low power standby mode. So we need to do anything to sort of wake it back up again. We'll go ahead and just tap the top to trigger Siri, which will wake up the amplifier there, and we will check our DC offset measurement. And you could barely ask for much better than that. We've got about 4 to 6 millivolts of DC offset here. So much better than that 600 millivolts on a cold boot that we were seeing earlier. And most likely, this is going to completely get rid of those death fart issues. So, we're going to put this back together. Make sure it's all nice and put back together well, of course. And then, after the stream, we're going to leave it plugged into power overnight, just to make sure that it doesn't start farting on us again. Just to make sure. But so far, we've been successful on all of these death fart repairs and such. Alright. Here is our shell. Drop that amp right on in. Oh, let me turn the fan off. I'm being silly. We don't need that on anymore. $14 screws for this amplifier. iPads are hell to open. Yeah, I bet. I've worked on older iPads, but never anything as new as any generation iPad Pro, really. I've only worked on older stuff. Hey, welcome to the chat. Sending my HomePod very soon? Very nice. Can't wait to fix it for you. I don't care if it's the same issue as all the others or if it's a brand new issue. It's okay, I fix. Okay, what if I start up a new company that like fixes the things that You Break I Fix breaks, and I'll name it You Break I Fix I Fix. You break I Fix break I Fix. Yeah, that would make more sense. Amp secure, dropping in the power supply, making sure the holes are lined up before we push that down and lock that connector into place. Then we can reconnect that power connector right there, screw it back in. See any goofy spots in the adhesive here? Nope. Oh, let's get you guys focused in there a little better. Oh yeah. Drop the bass in. fun games. What's going on there? I'll cut you out if you don't play nice. There we go. Jeff asked, what screwdriver is that? This is the ES15 motion control made by Miniware. One of our previous repairs, their name is Jim, had bought 2 of these for us to try out. And so far, as you guys can see from the past few live streams now, this thing rocks. It's way faster than I can put in or take out screws. It's got 5 torque settings. The highest torque setting seems to be strong enough to take apart pretty much every screw out of this. It's small enough to get to most areas, although if you want to use it on the amp, I would suggest a longer bit. It's got USB-C charging, which personally is my favorite thing about it. I'm still pretty far behind on most things, and well, it's to me still a luxury to see USB-C on any of my devices. But I also like that you can use it while you've got it plugged in and charging. So that is a huge bonus too. OLED screen, it's got a manual mode where you just push the button and it turns the direction that you have it set to. But I've got it set to fully automatic mode. And how that works is you push down the button and that turns it on. But based on which direction you start twisting is the direction it actually goes. And it goes faster or slower based on how much you actually twist. So it's motion controlled and works pretty well once you get the hang of it. It did take a day or so to really get the hang of it. But out of this one, and where's my other one? Here we go. And this one. So this is a Hoto Mini. It's not nearly as strong or fast. This one, this is the big Hoto. This thing's got some torque. Unfortunately, it's got too much torque to really put any of the screws in. As far as getting stubborn screws out, we break this out for anything that really is starting to put a fight up. So Not sure I would really recommend this. It's too slow, and for something this small to have any real benefit for me personally, it's got to be able to take the screws out and put them in faster than I can. But that said, I do carry this around with me most places that I go, just to have an extra little kit with a bunch of common bits in there, just in case anything comes up. Alright, we're putting this frame in for the logic board and the mesh. We're not tightening those screws all the way because there's a lip around this frame here that the mesh actually feeds into, so we're going to pull those drawstrings up and use our other hand to sort of squeeze that all around into place. And then we're going to take these and just pull them apart one more time to make sure it's nice and tight. And we'll push this frame down and just hold that down and screw it in place. You can let go of the drawstrings too once you've started holding this plastic frame down. Go ahead and fix that power connector there. Make sure it's centered and snapped into place if it's not. And we will screw our drawstring into place. Not too tight. The threads for these screws here and here strip rather easy, so this isn't really keeping your mesh tight. It's just really there to hold your slack into place. Or actually, let me correct myself. Yes, this is certainly going to keep the mesh tight if like someone goes and like starts pulling on it, but it's not really doing anything to hold any sort of real resistance. You don't need to tighten them down so much. Just snug enough to hold that drawstring in place. Our display, get that plugged in. Alright, before we stick our top on, let's just make sure the volume buttons aren't obstructed in any way so that they light up nice and evenly. Alright, let's slap a little heat on there, get that adhesive nice and sticky again. If you don't smear your fingers all over it, it should already be pretty sticky and reusable, and we just like to use a little bit of heat to get it nice and soft and stuck on there as best as we can. If you try to do heat yourself on here, just be real careful. You don't use too much too fast. Melt your parts. Make them deform. All right. Let's plug this into power and give it a quick sanity check. Beautiful.
Having trouble connecting to the internet. For more info, check the home.
No significant popping, if any, that I could hear. And the volume buttons light up nice and evenly. Amazing. So, we will set this to the side, get it plugged back into some power, let it run overnight, make sure that it's all hunky-dory before we send it back to Jeff. Based on our experience, though, I think we got him fixed up. Better safe than sorry, though. You never know. We think we know, but you never really know. So here we've got HomePod number 2. This one's from Ben, and it's got no power. Let's get that text on the screen updated there. And go ahead and confirm our symptoms here. Plug it into some power. And yes, indeed, no signs of life or response. Our kilowatt meter says we're pulling about 4 watts from the wall. So based on that power draw there, I'm going to go ahead and take a wild guess here that we've probably got the same thing as all others, or most others I should say, that shorted diode on the amplifier. So let's crack it open, see what's going on from the inside. And you are welcome, Jeff. Always a pleasure. Thank you for watching. Thank you for trusting us with your pods. Yeah. All right. Who wants to bet that the bottom of this display has a little dent in the middle of it? Take note of how far we've inserted our pry tool here. I'll go ahead and actually put a little mark on there so we have a bit of reference. But I swear, half of these displays are beat up straight from the factory. So that's only how far we've ever put that spudger in. Obviously the plastic one not even as deep. We're just gonna go around. And how much you want to bet this has a fat dent under it? Like most others we see here. Maybe I'll make myself look like a fool and it'll look just fine. Oh, yeah, that one's fine. Well, I can't complain about that. But let me find another display here. Yeah, look at this. What's the dealio? Because we only put our tool in about that far. There's no way, even all the way in there, it can't reach. So that's from the factory. Why'd they do this? Anyways. Go on, get on there. Okay. Oh, of course we got this. Of course we got this. You doubt the Knicks fix? There has never been a no power we have yet to conquer. Come on. There we go. All right. You know what time it is? Oh, you're gonna put up a fight, aren't you? Yeah. No match for the big fat flathead. No match. Easy peasy. Get out of here. It's time for the woofer check. Voice coil looks good. Feels nice and smooth. Yes. I'm not addicted. You got it. You got to sniff your speakers. Smell those subwoofers. Oh, okay, it looks like it's just about time to unscrew that amplifier. We passed 600 subscribers. Thank you guys. I honestly never thought we could have gotten this much, you know, business and subscribers and all that just doing this. But just you guys stay tuned, because I've mentioned it in a few past live streams. I plan on putting out a new video soon, a new upload where I fix like 10 or so broken HomePods that I've bought for myself. And we'll do a giveaway for one or two of them that we fixed, and we're also going to give away a broken one to somebody who would like to fix it for themselves. And the game will be take a drink for every HomePod I can fix until I can't fix them anymore. But stay tuned. Get subscribed. Keep an eye out for that video coming out in the next few weeks. You'll have a chance to win either a fixed working HomePod or a broken one to fix for yourself. And I'll be sure to make it so that people get to choose which one that they're sort of entering for, so that way you're not stuck with a broken one if you don't or can't fix it yourself. Alright, so there's our main culprit. We're going to set our multimeter to continuity test mode. If it detects continuity, it'll beep at us. In some cases, like this diode here, if it beeps at us, if we test this diode, that means that it's most likely got a short. It could be coming through the board, but based on our experience here, fixing so many of these, if there's a short on this diode, every single time we've had these in for repair, it's always been the diode. Yep, and it's dead. So let's get that replaced with a new one. See if this board powers up. There we go. Dead diode be gone. Of course, it's got a date code of 1746K on it. Let's grab a brand new diode from our parts. Get that prepped. All right. There we go. Brand new diode. Let's cool this board off real fast, just a few seconds in front of the fan. And then we will see if this board powers up. Of course, we're gonna have it connected to our multimeter there so we can double check for any DC offset issues as well. Make sure that those filtering capacitors are still operating within spec. And then we'll throw it back together. Okay, so power supply. We've got a significantly larger than average number of views. Did someone post something somewhere? Or did I just pick the perfect day and time to start my stream for today? Don't forget to set that meter into DC millivolts mode. Get our power connected to here. And drum roll, please. Booyah, we got power. Ah, okay, that makes sense. Cool. Well, I appreciate you sharing, even if people are just going to drop by and watch for a few seconds. If it gets one more person potentially doing their own repairs or saving a HomePod from the dump, then that makes me happy. What do we got? Oh, beautiful. We've got a really low DC offset of around 1 to 2 millivolts here. So that is excellent. And I heard, yep, base is working just fine. So this HomePod is ready for some action. Let's get it thrown back together. I have fans at Apple. Oh, that's nice. That's good to hear. I love it. As much as I talk crap sometimes, I mean, I still find myself going to my iPhone and my MacBook and my iPad and my AirPods and my HomePods more than anything else out there. Apple makes good stuff. They tend to make mistakes. Everyone does. It's what you do when you learn those mistakes. When you learn about those. That's what matters. I honestly don't even believe that Apple had any idea of any of these hardware defects or potential issues until after the HomePod was released and the problems started occurring. But once you find out your product does have an issue, you should be there should at least be options for you to do something about it instead of being stuck with it. If anybody at Apple is listening, though, that has the capability of getting out the software that we need to restore bricked HomePods, wink wink. Nah, they would probably be able to figure out who did that, and I don't know what would happen. If that came from like someone inside, that would probably be a big no-no. I disassembled my HomePod today. It was relatively easy due to the live streams. I found using a heat gun worthwhile. Oh man, the heat gun was a game changer for me. I found on the board the resistor is missing. Oh yeah, I think you posted in my Discord server too about that, didn't you? Good find. I don't often see that resistor completely blown out, but sometimes we do. Usually when there's a really nasty case of DC offset, do we see that completely blown out. Surprisingly, most of the ones that I've seen that resistor missing on have otherwise worked relatively fine. Like the base worked fine for a few minutes before death farting. But without that resistor there, it was interesting. How's the glue look on this one? We don't care if it completely covers the whole ring. All I'm looking for is if there's any bits of it that are going to keep the basket here from sitting nice and flush. That's all I care about. Because at the end of the day, there's this, there's your actual gasket here that does the job of sealing the HomePod sound up and nice and neat. Keeps it nice and sealed inside. This glue seems more of like a overkill, secondary failover kind of thing, just to keep things from potentially coming apart or rattling. But I found it to be unnecessary. Again, my opinion. People always say there's a reason they did it. People don't say specifically for this, but people say, that something's always done for a reason. A company wouldn't just do something for no reason, especially if it costs them any amount of money or time. But many people think that the glue was just put there to make this more difficult. I'm not sure how much I really believe that. They probably thought it had a legitimate function as sort of a backup. But if that was the case, then you'd think they would have designed it to be a little more repairable. Something that would last a little longer. Something that you could at least restore the software on if it breaks itself. I'm just rambling. In any case, I've already done like a side-by-side test of a HomePod that's never been opened with the original glue still in there, and then one that I've completely cleaned all of this glue out of, and they performed exactly the same with no issues. So we don't worry about that glue if it's not perfect, as long as it lets us put that basket back down nice and neat. That's what matters. Alright, for this gasket here, this is not something that I covered in my original disassembly video. Never even actually noticed at the time until recently. But if you look, right there, there's like a flat spot on the outer perimeter of this gasket here. And that is supposed to go right under your ribbon cable here. It's not the end of the world if you've put your HomePod together with that not oriented exactly like that. But if you want to do it the right way, then that's how you do it. You won't notice it at first. You gotta really look for it. I couldn't agree with you more. These things are absolute engineering marvels. I've said it a million times on the channel. To this day, this is still, in my opinion, the best speaker that you can get. Even for the original retail price that it sold for, to this day, the best speaker you can get for what it is. I'll say it again, as I said many times before. You get a dedicated big fat subwoofer. You get 7 BMR speakers that cover the high and mid-range sounds. You've got basically an iPhone 6 crammed in there to do all the processing. Siri with HomeKit integration, so if you've got a smart home, you can mess with all of your smart stuff. And a beautiful design. All in a single piece of integrated hardware that you just plug into the wall and connect to from any of your Apple devices. Man, I love it. and just purely from a sound and listening experience perspective, I'm not an audiophile, I would think, but I definitely do have, I consider myself to have a decent, like, discerning ear and being able to hear what sounds good and what sounds like crap. And to me personally, almost all Bluetooth sounds like crap. It sounds less dynamic, sounds it's never, and that's just the listening, like how it sounds. Like, you've got all of the problems surrounding Bluetooth too. Like, it's so frustrating dealing with Bluetooth, but I like AirPlay. I like that it works with Wi-Fi and it allows you to stream higher quality music. So with that, sure, you can't play Bluetooth with it. That's what a lot of people don't like, but I would never use Bluetooth on them in the first place, as would, I imagine, most other people that own HomePods, because they prefer that higher quality. Yeah. But man, get like 8 to 10 of these in a small to medium sized room. It totally rocks your socks off. Oh, and it's got the, it has room correcting, so it'll calibrate itself based on where you place it anywhere in the room to sound great. Like, they've got, like, sure, Sonos has some options, but again, there is no direct, in my opinion, there's no direct competitor to what the HomePod offers in terms of music, like playback performance. Come on. There we go. What can we do to prevent issues? For example, death farts are just bound to happen because of bad parts. So, there's really not anything you can do to prevent these issues, unfortunately. The most common issues being death farts and the sudden no power caused by the shorted diode. There really doesn't seem to be any way you can prevent these issues. It does just seem like parts that were maybe a bad batch or poor quality or not suited for the task at hand. So the best advice I can give is to just not worry about it. Use your HomePod the way that you want to use it. Get your enjoyment out of it. And don't worry about it. Once you start experiencing those issues, then worry about it and take it apart and get it fixed or whatever. But there's no, like, you can't condition your power or like get a 120 to 220 volt AC converter or vice versa. You can't put it on a surge protector to prevent these issues. The only way you can really prevent these issues is by taking it apart and replacing the parts that are going to eventually fail. And unfortunately, we just, me personally, I don't have access to, like, the metrics or the data that would allow me to make a certain, like, a certain call as to whether it's bad quality parts, not suited for the design. Like, I don't have access to schematics, and I don't know how many of these were sold. So sure, the date codes on these diodes might seem to lead to a coincidence that there's a specific batch of diodes that were bad. But it could also just simply be that they used so many of, when they bought the order of diodes, they just got more of these. So they manufactured more HomePods with these date codes. So we're just going to see more of these failed than the others. But unfortunately, well, I will say this. I will say that I suggest you do have it at least on a surge protector, so that way if you ever have a power surge at your house, you fry your surge protector and not your HomePod. I suggest you do that for any of your electronics that you remotely care about. If you don't want to have to replace it, put it on a surge protector, and not those dinky dollar store power strips. A legitimate surge protector. Legitimate surge protectors aren't that expensive either, but it's got to be an actual, surge protector. Yeah, as I say, correlation isn't always causation. Just because we see all of the diodes that fail have the same date codes doesn't mean that those diodes with that date code are part of a bad batch. It could very well just be that Apple just happened to have more of those on hand when these HomePods were assembled, so we're just going to see more of them fail. That said, if you look at our parts here, these are all of the ones that have failed. Every single one of them has 1746 or 1748K on it. They've all failed the same way. These are all the ones that we've replaced from HomePods that have come in for unrelated repairs. Like I said, we replace this diode every single time a HomePod comes in, regardless of what it comes in for. We replace this diode. So I keep those old ones. And every single one of the dead ones have 1746 or 1748K. All of the ones that were still working when we replaced them, some of them have 1746 or 1748K, but most of them have date codes much older or much newer than that. So it is at the very least a very strange coincidence. But I'll give them the benefit of the doubt. And also, how would you even be able to know that until it starts happening? It goes back to what I said earlier. It's not about making the mistakes. It's about what you do with those mistakes. And in my opinion, Apple does not have a great track record of taking responsibility for their mistakes. They like to blame the end user or just outright ignore them. That's really the biggest pain that I have with them. Aside from that, I absolutely love and I'm a huge fan of their both their hardware and their software. As I said, I daily drive all of it. It's typically my go-to. I finally actually convinced I didn't even have to convince her. She saw the Apple Watch Ultra announced, and she was like, I want one of those. And she's been like a hardcore Fitbit user for years. So maybe she'll get a nice Christmas present. It's so much for a smartwatch, but I know she'll absolutely use the crap out of it. Alright, the final 4 screws. And then the moment of truth. Someone asked if I found this nerve-wracking. I said, at worst, I'm out of dead HomePod, and those aren't that hard to get here in dead ones aren't hard to get in San Francisco, or just working ones in general? Also, there's nothing to fear. No power issues have been a grand slam repair every single time. Take a look at how many diodes are in there. That's how many HomePods have come in for no power alone. There's at least 200 to 250 diodes in there just for that issue. That's like 9 times out of 10 what happens with these no power ones. The other times, it's ended up being a short on the amp or on the logic board. And between the traditional flux method, or rubbing alcohol, and our fancy thermal camera, we've been able to find and fix every single logic board that has had a short, causing no power issues as well. But those are the only 2 failure modes that we've seen that cause no power after having gone through hundreds of these repairs by now here on the channel. So we can say with quite a bit of confidence, fear not for no power, we can fix it. Yeah, you got that right. Oh, the being able to live stream the repairs for you guys is just icing on the cake. I like to say it, as a kid, I always remember it was so cool to go to the tire shop or the mechanic with my mom, because they would, like, most of those places, like, have a waiting area that you can sit and watch your car being worked on. And I always thought, well, why can't, like, tech repair be the same way, yeah? And then you have other channels starting to do the same thing, or pretty similar, like Louis Rossman and Northridge Fix and what have you. But I also saw that nobody was taking care of HomePods. There were a few people that tried, but I saw an opportunity to crack a real tough egg there, and I'm quite happy I did. It gave me an opportunity to get my hands on so many broken ones for myself and build up a really good collection and just a really nice audio setup throughout the house. And it also got me a lot of experience doing electronics repair and getting my name out there and, you know, starting a little business, helping out the planet a little bit. People spent so much money on these things already. To me, it just seemed so wrong that they were being asked to basically spend the same amount again for something that's just going to end up having the same problems. So I saw a way to fix that, and I'm really glad that I'm able to. I'm very fortunate that I can offer it at such a reasonable price too. this isn't my, I don't live off this, but it definitely does make living a lot more comfortable. Yes, we got power. Go ahead and turn the lights off so you guys can see it a little easier. There we go. What's my day job? So I am a sales engineer for a local software company. Thankfully, I get to work from home, and my schedule's pretty flexible, given that I'm also flexible with my schedule. It's give and take. Some days I'm splitting my hours up. I don't, I'm salary, so I don't necessarily clock in or clock out, but I do keep a sort of mental tally of how much time and effort I'm spending for the day. And sometimes I'll split it up. Sometimes I'll just work the whole day through and then knock out all of my repairs in the afternoon or evening. But I've been a software or a sales engineer for the same software company for around 10 years now. Basically what I do is I help the sales guys set up or demo or train on our software, or help integrate new hardware into our software, or just general tier 2, tier 3 troubleshooting. I absolutely love working there, and I've been there for over 10 years now, and I don't think I'll be leaving anytime soon unless my side repair business here just ends up taking too much of my time. I would rather keep things the way they are now, where I can do this sort of stuff in my free time. But if of course I had to choose between one or the other, I would have to charge so much more for my repairs to make it viable for me to leave my current day job. And also I've put so much time and effort, and I do quite care about where I work at and our customers there, and the people that work there, and I couldn't just leave them. You couldn't just drop everything and leave them for the sake of pursuing my own repair business. Not at least until it was growing so much to the point where I could really depend on it. But okay, enough of our rambling here. Let's see if we've got good sound.
I'm having trouble connecting to the internet.
Oh, I'm sure you are. You're far from home.
I'm having trouble
and our volume buttons light up nice and evenly. So folks, we got everything sent in today fixed up. Yeah, that's everything. So, if any of you have any questions on any of the repairs that we've done today, or any repairs in general, you're more than welcome to leave a comment down below. I always suggest, of course, everybody first checks my website at the bottom right there, nixfix.com. I have a dedicated section there for common issues with Apple HomePods, including each issue will have known ways to diagnose and repair those issues, and any parts and specifications of those parts that you may need to actually fix that issue. If instead you'd rather mail your HomePod in for repair to be here live on the channel, I've got my contact info and mail address on my website up there as well. Yeah, do check out that website. If you're any familiar with Apple's website design, you might find it a little familiar. Maybe you actually saw the original HomePod website a few years ago while it was still an active and supported product. It took a long time for me to get that website looking the way it is and working without issues. So yes, please give my website the hug of death. And don't forget, it's optimized for Apple devices. So if you're on an Android, then oh boy. Well, anyways, thanks everybody so much for joining. Don't forget to subscribe and hit like if you liked these sort of repairs. And I'll catch you all in the next one. Goodbye.